All right, so this is 2.2. We are going to be practicing solving one-step equations. Now, before you begin, over here on the side of example 1, I have this little checklist that I want you to pause the video and write this down. You could write it here, you can write it in the front of the unit. We're going to be referencing this a lot, and I want you guys to try to memorize this checklist. This checklist is a step-by-step instruction in how to solve any equation ever. And we are going to be getting into more difficult equations, and it works whether it's simple or whether it's difficult with multi-steps. So step number 1 is simplify both sides. When I say both sides, I'm talking about the left and right side of the equal sign. So simplify everything on the left side until there's no more like terms, and then move to the right side. Now, sometimes they're both simplified, or you only have to simplify one, but don't move on to step 2 until both sides are in fact simplified. Then step 2 is move variables. And I want to say variables because this applies where there is more than one variable. Now, a lot of times, again, like in the problems in this section, we're only going to have one, so we don't need to worry about that. But we are going to be doing number 3, which says move the numbers or the constants, the ones without variables. And that means we are going to move them away from the variable. That is the biggest thing. Our goal to solve is to isolate the variable. That's step 4. The whole point of this is that everything that is not the variable is going to move to the other side of the equal sign. And you know you are done when you have a single positive variable on one side of the equal sign. Then the last step is to check. You want to check to make sure that it works. With equations, you are able to double check and make sure that you know you are right. And one thing I did want to highlight here is the phrase move. I put that there because I think that's just a nice, easy phrase to understand. But when I say move, that means very specifically you move with the opposite operation. Meaning that if there is addition, how do we undo that addition and move it to the other side? We subtract. And how do we get rid of subtraction? We add. Multiplication, we divide. Divide, multiplication. So whatever you have on one side, if your goal is to eliminate it from one side and have that value put on the other side of the equal sign, that is what I mean by move. Okay, so move with the operation. So if you're combining like terms on the same side, you do not do the opposite sign, okay, or the opposite operation. Now, what I do want to point out here is that I think this book does a good job of showing the two main ways of writing out how to solve this. What I will say is that the horizontal method, which is over here, most students don't like to do it this way. Which I really understand because you guys are really used to adding and subtracting vertically like in the other method. But this is primarily how books and online resources show it. And all it does is save paper and space, which is why they prefer it. So this is what I'm going to call book method. You can absolutely do it. It's the same thing, but it's not necessary for you to do it. But it is necessary for you to understand that this is what it looks like if you are reading this in the book. Okay, so this says g minus 25 equals 113. Let's go through the checklist. Okay, 1, simplify both sides. On the left side, g minus 25, there are no like terms. Let's go to the right side, 113. There's only one number there, so there's no like terms. Move on. 2, move the variables. I only have one variable, so therefore I don't need to move any of them together. 3, move numbers. I do have numbers that need to move together, and I'm going to do that in order to isolate the variable step 4. Now, what I mean by that is, could I move the 113 over here? Absolutely, I could, and I would be left with a 0, but why would I do that if my goal is to get g by itself, right? I want to get g by itself. So I'm not going to do that. You have to decide. So right here, g is already positive and alone on the left side. So that means that everything that's not g has got to go to the right side. So we're going to be moving the negative 25. And I'm going to do that by eliminating it from the left side and moving its value to the right side in order to keep this balanced. So how do I get rid of a negative 25? The opposite operation of that is positive 25. Now you have to do it on the left in order to keep the equality on the right. So whatever we do on the left, you do on the right. That's negative 25 plus 25, which is 0. So G plus 0. But we don't ever have to write this step because, well, it's 0, right? So you don't have to write that. So instead, you're just left with a G. And then on the right side, we're going to add 25. Okay. Now, again, a reason why a lot of students don't like to do this is because you have to do this either mentally or you have to kind of do the vertical method that you did. So 3 plus 5 is 8, 1 plus 2 is 3, and then the 1. So G is equal to 138. And this right here is exactly what I mean about it being positive and alone. I want you guys to take a mental snapshot of this image. Okay, for this image, G, or whatever the variable is positive, and there's nothing else next to it. There's not a number. Well, there is a number, isn't there? There's a number 1. Okay, when I say alone, some students mean that there's a 0 here. No, there is a number 1. Now, in math, we don't really need to put a 1 here because we only see 1 G, so it's just implied. But if it was like a 2, we're not done. You are not done until the only thing that remains is a 1. Now, if it helps you mentally, you could go ahead and put a 1 here. I will never discourage you from doing that. Just please know you're never going to see that like in a example. Okay? All right, let's move on to the other way. Now, this is the vertical method, and the vertical method tends to be the way that most students like to do this, okay, because it's easy for you guys to add and subtract on the other side. So same idea, go through the checklist, no like terms on the left, no like terms on the right. I only have one variable, so I don't need to move it. Now it's time to move numbers. I need to move the negative 25 away from the G. So that means I'm going to move it from the left to the right. That is a negative or a minus 25, which is the same. Please note that a plus and a minus, that is the same as just subtraction. So that's why I keep saying minus or negative 25. They're the same thing mathematically. So how do I get rid of a minus? I add. So I'm going to add to the right or to the left, and it cancels out, and I'm left with the G. And again, G is alone and positive with a 1 in front of it. And then 113, I'm going to add 25 to that, and that is 138. So G equals 138. And I can now check my work. I can check by mentally or working it out, but if I put 138 back in this problem, instead of the G, 138 minus 25 is 113, and because my problem on the right side already had 113, they are the same, and that is how I know I'm right. I'm going to really push you guys to know if you are correct with this unit. There is zero reason why any of you guys turn something in or do an assignment, a problem, and get it wrong. You don't have to get it wrong. You can check your work and make sure you are correct. Okay? All right. So let's go ahead and look at this one. It says solve this, right? State which property of equality you used. So this just simply means like, what are we going to do to solve? Okay? And for this problem. Cut this out. All right, let's go on to example 2. Now, please understand the checklist is exactly the same. Hopefully you wrote this down so you can reference this, but it's the same idea. In this problem, I originally have addition. Okay, so I know it says subtracting, but that's because that's how I'm going to solve this. Okay, so for this one here, I have 27 plus k equals 30 originally. I'm going to go ahead and just do the vertical method because I know that's the method I'm going to be doing primarily. And so let's go through the checklist really quick. No like terms on the left, no like terms on the right. I only have one variable, so I don't need to move. Now that means I need to move the numbers. My variable is on the left. I'm going to identify my variable. That means that everything that is not the variable has got to go. It's got to go to the right. We're going to move it. How do I move this positive 27? What's the opposite of positive? A negative 27. And remember, negative is the same thing as minus. I know it's kind of confusing because I'm using those words interchangeably, but that's because you need to understand they mean the same thing mathematically. Okay, and we already talked about that, so just hopefully you kind of understand that by now. And then 30 minus 27 is 3, and k equals 3. And then all you do is look, okay, my k is alone, nothing else over here. It's positive, and there's only a 1 here. And again, you can put the 1 if you want, but you don't need to. And k equals 3. Last step, check your work. 27 plus 3 is in fact 30, and my original problem had 30 over here, therefore it is correct. All right, I want you to give this one a shot. Pause the video and give it a try. Okay, let's see if you got it correctly. So I have a plus 26 equals 35. Step number 1, any like terms on the left? Nope. Any like terms on the right? Nope. I am going to go ahead and look at my variables. I only have 1. I don't need to move anything. Step 2, I'm going to go ahead and move the numbers, my variables on the left. So that means everything on the left has got to move to the right. We're moving it to the right. This is a positive 26. So that means I need a minus 26, minus 26. This goes away, and I'm left with a positive variable with nothing else besides the number 1 in front of it. I'm good. Over here, I have 35 minus 26. That is 9. Go back and check your work. 9 plus 25 does, in fact, equal 35. I am correct. Oops, I messed up. Go back and check your work. If I plug it back in, 9 plus 26 does in fact equal 35. I am correct. So that is how you do one-step equations with addition and subtraction.